Hi everybody, the first thing I wanted to show you is a simple example of matrix inversion. So let's consider the following matrix. So let's suppose I have A is equal to 2, minus 1, 0, minus 1, 2, 1, 0, 1, 2. And my goal is to compute what A inverse is. So how would I do that? Well, I basically set up my augmented matrix. Only the deal is, I'm going to augment, instead of just a column, I'm going to put the entire identity matrix here. Then I'm going to put this entire left-hand side into reduced row echelon form, and whatever I get over here on the right-hand side, it turns out is going to be A inverse. So we just do Gaussian elimination to get into reduced row echelon form. So of course the first step is put a pivot and or turn the pivot into 1. So I have 1 minus 1/2, 0, 1/2, 0, 0. I'll have minus 1, 2, 1, 0, 1, 0. This is always a little bit of an arduous computation. There's a lot of things to copy, and because you're copying a lot of things and you're performing a lot of steps, a lot of errors can creep in. But at the end, you can always check yourself, and I'll show you how to also check yourself. So now we're going to add a copy of row 1 to row 2. And what do we get? Of course, that clears out my column completely. When I add a negative 1/2 to 2, I get 3/2. I still have a 1 here. 1/2, 1, 0, 1, 2 is still here. 0, 0, 1. And now this is my new pivot entry, that 3/2, and so I have to multiply the row by 2/3. And of course I'll get minus 1/2, 0, 1/2, 0, 0, 0. Now I have a 1 here, I have 2/3 here. This will become 1/3. This will become 2/3. And I have a 0, and the final row is what it originally was. Nothing's changed to that row. And now we clear out the entire column for this pivot. So we're going to add 1/2 of row 2 to the first row, and we're going to subtract off 1 copy of row 2 from the third row. What do we get? Well, in this case we're going to obtain 1, 0, 0, 0, 1, 0. That was the goal. Now I've added 1/2 of 2/3 here, so I'm going to have 1/3. I still have 2/3 in the second row, third column, and then I'm going to subtract from 6/3, i.e. 2, 2/3, and so I get 4/3 down here in that entry. Now this gets a little more tricky. I have 1/2 and I'm adding a 1/6. 1/2 is 3/6, and I add another 6, so I have 4/6. Simplifying, I have 2/3. 1/2 of 2/3 is 1/3. 0. I still have 1/3, 2/3, 0. Now I've subtracted off exactly 1 copy of this row from this row, and so I'll get 1 minus 1/2 minus 2/3, 1. Now I'm nearly done. Of course, I just basically have 2 steps, so I'm going to first multiply this guy by the reciprocal of 4/3. Now I have a 1 in all the pivot entries, and the final operation is to clear out the last pivot column. Oh yeah, we have to be careful. Right, so minus 1/2 times 3/4 is going to give us what? It's going to give us, oh sorry, this should have been, remember this should have been minus 1/3. And so you have to be very, very careful. Of course, we just made one error in computing this guy, and it can completely ruin what we've done. So now minus 1/3 times 3/4 is going to give me minus 1/4. I have minus 2/3 times 3/4. The 3's will cancel, and I get just a minus 1/2. And finally a 3/4 in the very last entry. And now I just have to clear out these columns. So minus 2/3 row 3, and then minus 1/3 row 3 here. And what do I get? Well, like I said, on the left hand side, I get the identity. On the right hand side, let's first compute this row. I have 2/3 minus 1/4 times minus 1/3. So that's plus 1/12. Now 2/3 becomes 8/12. So ultimately I get 9/12, and when I simplify, that's 3/4. Now I have 1/3 plus 1/6, which is 2/3 plus a sixth, which will give me 1/2. Now finally, 3/4 times minus 1/3 is minus 1/4, and that's what I obtain in that entry. Alright, now computing the second row, we have 1/3 minus 1/4 times minus 2/3. That'll be plus 1/6. So I have 1/3 plus 1/6, which we've seen before is 1/2. Now I have exactly minus 1/2 times minus 2/3 is going to be plus 1/3 to 2/3, so I get a 1 in this entry. And then 3/4 times minus 2/3, the 3's will cancel, and I'll get just a minus 1/2 in this entry. And everything else stays the same. In particular, we can now write what A inverse looks like as a matrix, and we just basically copy this guy. 3/4, 1/2, minus 1/4, 1/2, 1, minus 1/2, minus 1/4, minus 1/2, 3/4. And we can also verify, right? What's the whole point of A inverse? Well, A inverse times A has to be equal to the identity matrix, right? So I should get the 3x3 identity matrix when I perform this multiplication. So let's go ahead and carry out that multiplication, and that'll check that our answer is correct. So I have 3/4, 1/2, minus 1/4, 1/2, 1, minus 1/2, minus 1/4, minus 1/2, 3/4. And our original matrix was 2, minus 1, 0, minus 1, 2, 1, 0, 1, 2. And so now let's figure out what those entries are. So I've got 3/4. So the 1, 1 entry I get by multiplying the first row times the first column. So I have 3/4 times 2 will be 6/4. Then I have minus 1/2. In terms of fourths, that's 2/4. So that'll put me at exactly 4/4 so far, which is 1. And then I have 0 times negative 1/4, which will be 1 plus 0, which is 1. So we're in good shape so far. Now 3/4, 1/2, minus 1/4. Well, up here, that'll be a minus 3/4. Then I'll add exactly 1, which will give me positive 1/4. And then minus 1/4 here, which gives me 0. Things are looking good. Finally, the 0 is going to cancel out to 3/4. Then I have 1/2 minus 2/4, which is minus 1/2, and I get 0. You can carry out this computation fully to check yourself, but ultimately you get this as the solution.